here's the implementation of that square root compute, and in the form of getting the hypotenuse of a vector. So here it is here. So I get x and y, I absolute them, then I sort y and x. Then I compute the first error. There's that fudgy constant. The constant appears 3 times the same, so it's the same. So I get the first error, then I do some inversions, then I get the second error, then I do some inversions, get the third error. So that's the first triangle, there's the second 2 triangles, and there's 4 triangles. X plus y, take E1, take E2, take E3. And here I'm comparing against square root, and it's not exact yet, but I think you can get it exact if I could just get my brains together. But there's 45 angle, 214, that's using it his square root function, and here's my one, 214 just off. Try a different amplitude at 45, and then you get 73, 73. Now try a funny one, 152, 52. Look, off by 4. But it won't be, it's not more than off by 4. I think there's probably a bug in it, because it should be better than that. But then 32, 82, off by 1. 132, 682. This, the bigger the number, the bigger the error is going to be. And this one's off by a fair bit. This one's off by 15, 13. But they're pretty big numbers. 232 and 62. And it says the hypotenuse is 288, 294. So in this one we're off by 6. But it mostly works. Just do one more. But I think I can actually get it. I should be able to get it so it's exact if I just put a bit more code in it. So there you go, off by 1. So what makes this more optimized than say someone else's one? Well, there's just adds there, and you can see all the divides and all the multipliers, they're all constants. So that's just a constant. And so all I can say is it does have multipliers in it, but they're all constant multipliers. So they're slightly better. Even in software they're slightly better if you do them in sum of shifts. If you do them in sum of shifts, then they're slightly better, but in hardware you can just use a resistor. That's why the cool thing about them is in hardware it's actually pretty cool, this one, in the calculator. There you go, there's hypotenuse, and almost like a square root. You can see I've got some problems there, but sorry it's not fully conclusive. I can win, but I'm so tired, I can't do anything.